Hi, scientists. In our last lesson, we explored polarity and how some components only work if electricity flows in the right direction. In this video, we're going to start off with a little challenge. Using only the battery, wires, and LEDs, how many different ways can you create circuits that contain two or more LEDs? Pause the video now and see how many different combinations you can make. Welcome back. How many combinations did you come up with? Did all of them work? Why do you think some of them worked, but some of them didn't? Go and choose one of your arrangements where the lights turned on and one where they didn't, and draw the circuit diagrams for them. By the end of this lesson, you'll be able to identify parallel and series circuits from diagrams. You'll be able to explain how current flows through each type of circuit, and you'll be able to construct circuits to demonstrate your understanding of parallel and series circuits. When multiple components are in a circuit, they can be arranged in different ways. These different circuits can provide different pathways for the current to flow. Different arrangements will have different uses, advantages, and disadvantages. As an engineer, you'll have to choose which arrangement is right for you. Let's look at these two circuits. They both have the same battery, the same two LEDs, and wires to connect them. But because these arrangements are different, the electricity will behave differently. This first circuit is called a series circuit. It's called series because the components, in this case LEDs, are lined up one after the other. All of the components in the same line have to share the same electric path. If I remove one LED, it creates an open circuit and the current will stop flowing. This second one is a parallel circuit. It's called parallel because there's two separate paths running side by side. In this circuit, some of the electricity will flow through one path and some will go through the other. If there's a power disruption in one side, the other will keep working. As the engineer, you will choose which type of circuit will be the best fit. So far, we made some circuits that worked and some that didn't. What if there was a way to tell before we even built it if it was going to work? Well, there is. To determine whether or not these circuits are going to work, we first need to know about voltage. Voltage is the difference between the positive and negative sides of an electric current. We can measure the difference in volts using a voltmeter. We can measure either the entire circuit from one side of the battery to the other, or just part to find out how much voltage drop is happening for each component. In 1845, a brilliant physicist named Gustav Kirchhoff described a law that states the sum of the voltage in a closed loop is always zero. For us, that means the amount of volts the battery is contributing needs to be canceled out by the rest of the circuit. Let's see how Kirchhoff's law works in our two LED circuit examples. Let's first start with our series circuit. The voltage of the battery is 3.7 volts. According to Kirchhoff, we need to cancel out that 3.7 volts with the rest of the components in the circuit. That means the wire blocks and the two LED blocks need to drop 3.7 volts from our circuit. Wires are designed to carry power from place to place and use as little voltage as possible. Especially when wires are short, there will be little to no measurable voltage drop. So for our calculations, we can remove the wire blocks from our system. That leaves just our two LED blocks. Every electrical component has specific voltage requirements that can be found on the datasheet. The datasheet for this LED and resistor combination shows that it requires 3.0 volts to light each block. Let's add two of those together, and we'll see that the total is 6. Well, that's much higher than our battery. In fact, the battery can only supply about 1.9 volts to each LED block. Because the datasheet says it's going to require 3.0 volts to light the blocks aren't going to be able to light up. Let's go ahead and build the circuit and see what happens. Huh. Now, your first thought might be, maybe there's something wrong with my battery. I bet it needs charged. Well, there's nothing wrong with the battery or your LEDs. Even a fully charged spark block battery will not be able to light them up. There's just not enough voltage. Kirchhoff's law predicted it, and we just proved it right in our test. Let's now use that same law to examine a parallel circuit. The voltage of the battery is still 3.7 volts. That means from one end of the circuit to the other, we need to subtract 3.7 volts to get back to our sum of 0. As our current exits the battery, we're going to encounter a junction. When that happens, we need to think of each loop as a separate circuit, each with the same voltage drop. That means each loop has to drop a total of 3.7 volts. We can again subtract the wires from each circuit, and then we're left with a single LED. That gives the LED 3.7 volts to work with, perfectly within our operating range. Before we build this one, let's go ahead and make a prediction though. Are both LEDs going to light up? Is just one going to light up, or will neither light up? Once you've got your prediction and justification written down, let's build the circuit to see if we're right. Because this type of circuit's new, let's go ahead and build one together. We'll need the battery, 2 wires, and of course, our 2 LED blocks. I'm going to grab a red one and a blue one. I'll first build our LED circuit we've built before. Then let's add our LED on top. Now we have 2 closed loops for the current to flow. This type of circuit is great for running multiple things at once. Each LED lights up, and because it gets the full voltage of the battery, they're just as bright as when we only had one. However, because we're lighting both LEDs to their full brightness, the battery life is going to be shorter. Well done! That was a lot of learning, so let's review. In this video, we learned there's 2 main types of circuit layouts, series and parallel, and how to identify them from diagrams. We learned and applied Kirchhoff's law to explain how current flows through each type, and we built circuits to demonstrate our understanding of how they function. Now, with a better understanding of series and parallel, you can maximize your use of power and components more effectively.